Hello, ladies and gentlemen. My name is Wolfgang Vogel. I'm General Manager and founder of Vienna Water Monitoring Solutions. And I will give you a brief overview about the ColiMinder, our technology on fast and fully automated measurement of bacterial contamination in water. First, what is the problem we solve, or what are we addressing? If we're talking about water, there is a lot of chemical and physical parameters we are used to measure online, and these are used for quality control and process control. So there's sensors for all that kind of different parameters. But as soon as it comes to the microbiological quality of water, which is the one which has health effects right away, because if there's bacterial contamination, you will realize that after minutes even. If it comes to that water quality parameter, we want to evaluate this, we still have to undergo the process of taking the sample to the lab, process the sample in the lab, and that's the time when already the first health effects occur. But then we have to incubate it, and then we have to count the cell cultures that have been formed, and then we got a result after 18 to 72 hours. And that's exactly what we're addressing with our technology. We offer this important parameter within 15 minutes and fully automated. Is this possible? How does it work? So we have a look at the traditional method to evaluate bacterial contamination. This method is based on bacteria forming cell cultures. So a water sample is brought on a plate with growth media, and then we wait for 18 to 72 hours. And then we count the colonies that have been formed out of our sample. And this takes the time of 18 to 72 hours. So that's because the growth of the bacteria, something we cannot speed up. So we had to find another method, another solution to that, which is not depending on the growth. So what we do is we are directly measuring the metabolic activity of bacteria. Bacteria use enzymes for their metabolism, so we measure the enzymatic activity that is specific for our target organisms. Both methods are measuring a direct genuine property of living bacteria. If there's living bacteria, some of them can grow cultures. If there's living bacteria, every of the living bacteria has to have a metabolism, otherwise it's not a living bacteria. And by utilizing the metabolism of the bacteria instead of the growth, we can speed up the time to result from the 24 hours to 15 minutes. We are able at the time to offer reagents to detect E. coli contamination, coliform contamination, enterococci, or total bacteria. I'll give you an example on why this technology is revolutionary. It's just one example. I take something which is easy to understand, and if we think about a wastewater treatment plant or used water treatment plant, and if you want to dispose what's coming out of the plant into the environment, for instance, without any hazard to the people using that as recreation area, using that as water, we have to disinfect the outcome of the treatment plant, of course. So if we would evaluate what's coming out of the treatment plant, and we would do one sample a week, it would look like that. Single dots of results, that's the contamination level. So we would see that, not very much to see. If we would do a daily sampling, we would get these dots here, the green ones, And we see there is a peak here, a contamination peak. Contamination is about 2.5 times higher than here. But of course we would get these results always 1 day later, so too late to take any action on it. So if we now introduce our technology, the contamination timeline looks like that. That's an actual timeline of a sewage plant serving 1.5 million people. You see a daily fluctuation, a high towards midnight, a low in the morning. Sometimes things happen in the process, and then you've got a contamination peak just for a few hours. It goes down again. Sometimes contamination is higher, but you still got these daily fluctuations. So that's the real timeline of a real sewage plant. And as you see here, we get the result immediately. So 15 minutes after the sample has been taken. If we now think about our disinfection process, where we have to address the actual contamination, if we have got this daily or weekly sampling, we have to run a process at this level to be sure, to be safe, even if a high contamination is present, even if a peak occurs. We have to be safe, so we have to have a disinfection process at this strength, just because we don't know what actual contamination is present. If we now introduce our technology, we can exactly measure the actual contamination, and we can control the disinfection process according to what's actually in there. So according to that line. So we can run a process like this, controlled by the reading of our ColiMinder. And compared to the standard process, we will first gain some more safety here in the peaks, because we run the process for 30% higher level than it will be needed. But we will also generate about 50% reduction in process cost, because we don't have to use that high contamination or that high disinfection intensity all the time. And at the same time, we would be able to control or to monitor what's coming out of the process, to safeguard the whole process regime and to make sure that nothing's happening. So where could this technology be applied? Of course, water treatment, water reuse is a big topic. Process monitoring and control, surface and raw water monitoring, flocculation processes, all processes of filtration, disinfection, also network monitoring, but of course also in agriculture, aquaculture, food and beverage production, cooling water, process water, farm industries and oil industries. This is a short, brief overview of our customers up to now. So they range from oil industries to food industries, normal labs, universities, a lot of universities all over the place, but also villages that monitor their bathing water or their surface water, like Valmorin or city of Quebec. The technology has already widely been acknowledged. That was the second last prize we won at the International Water Summit in Abu Dhabi, but also several other national and international prizes and publications have been made. I thank you very much for your attention, and there's a short overview again. So this technology is able to reduce cost, increase safety, delivering results in 15 minutes. It's fully controllable through internet, also transferring the measured data through the internet, so you can monitor the actual contamination live on a website. And of course, which I think is a very good perspective, this technology is enabling new other technologies for water treatment, sustainable and new technologies for water treatment. Thank you very much.